So what we learned last week, or not last week, sorry, 30 minutes ago before you guys went to lunch. We were doing some more of those half angle or those sum and difference. What I'm about to teach you are the half angle and the double angle. So actually we're gonna do our identity sheet first. And then maybe we'll just stick to this page since we're already here, and then we'll kind of do as much of the another page and a half that we've skipped so far. So go ahead and get your identity sheet out. I have space like here. So I'm the right mind in this space. And if I need some more space, I'll write some down here. So the next two identities that I'm going to teach you, or two types of identities I'm going to teach you, are double angle and half angle. We'll actually start with double angle. So double angle identities. This is if I multiply an angle that we know by 2 in order to get this. So all of mine are going to start sine 2 theta. So sine 2 theta is the same thing as 2 times sine of theta times cosine of theta. And we're not really deriving these, I'm just kind of showing them to you and then we're going to use them. And right now it feels like maybe a little bit of nonsense, but I need to show them to you in order for us to use them. So I'm kind of handing you a tool. You don't really know what you're doing with it yet, but I have to hand it to you in order for you to use it. All right, for my cosine ones, I actually have 3 different ways to do cosine double angles. So the first way is cosine squared theta minus sine squared theta. The next way is 1 minus 2 sine squared theta. And the last way is 2 cosine squared theta minus 1. We're going to talk about in a minute why I would use one over the other one or why I wouldn't use one in this case, but they're all 3 of those are good options. And then the last one for my double angles is going to be tangent 2 theta. That's going to be 2 tangent theta divided by 1 minus tan squared theta. Let me just do a quick check, make sure I did that right. Yeah, minus is right. And then cosine squared minus 1 and 1 minus 2. Right, okay, yep. All right, I'm happy with those. Just want to make sure I got all my plus and minuses right. I was doing it from memory. So again, these were my double angle identities. So we're going to use them momentarily, but I wanted you to have those as kind of like a reference for what we're moving into. Next, we're going to talk about half angle identities. Same thing, I'm just gonna put them on the board, we're gonna write them down. Thank you. Take a second, make sure you have all of these down. And now for half angles. It's minus and plus. Minus and plus. And then I'll come back to this if we need to, but now I'm gonna go down to half angle identity. So this is just kind of the space I have for it. So half angle identities. Pencil maybe a little too fast for it. We're gonna do a sine and a cosine and a tangent, we've got sine of theta divided by 2, because that's what happens. These are all going to be kind of ugly. They're plus or minus these big radicals. And sine is going to be 1 minus cosine of theta divided all of that by 2. So all of that's under the radical. 1 minus cosine theta divided by 2 is all under the radical. My half angle formula for cosine is still going to be plus or minus, still going to be that ugly radical. But this time it's 1 plus cosine of theta over 2. And then tangent's going to be the combination of those two. My half angle identity for tangent is going to be plus or minus my big radical of 1 minus cosine theta over 1 plus cosine theta. Probably tomorrow when we do our review, I'll print off what like a real identity sheet should look like. And I'll probably end up giving you a written one for the test. That way there's no mistakes on plus or minuses or anything like that. And then that way you can kind of see what's going to be given to you for the test, or you can kind of fix your identity sheet. I think that there's some power in you guys writing them down and like taking time to make your own. That's why I didn't just hand you one. Okay. So once you have both your double angle and your half angles done, we're going to go back to number 5 on our notes. We did A and B before lunch. We're going to do C and D. Now those are double and half angles. So we're going to do a little bit of practice with double and half angles using kind of that problem we just started. And then we'll go to the back of 5-4 and see, or back to the beginning of 5-4 and see how much of that we can do. Okay. Everyone write down half angles or need a picture? Anyone need it for double angles? Everyone's good? Okay, moving on. Okay, so I'm still on number 5, which means that the triangles that we drew are still there. They're still relevant. Now we're going to do cosine of 2 alpha. So that's one of the formulas we just wrote down. If you remember, there were 3 formulas for the cosine double angle. Now, generally, there's often one that you should or shouldn't use for that. I would argue that all 3 are possible to use here, but I'm going to tell you one is probably best to use in this case. Of my cosine double angles, since I was given sine of alpha, I am most likely going to do the one that says 1 minus 2 sine squared alpha or theta or x or whatever you want to call it. I'm most likely going to do that one because they gave me sine. So for some reason, I messed up finding cosine. I know that I'm going to do this correctly because I'm plugging in the thing that was given to me. So since this was already given to me, I'm going to use sine alpha and I'm going to plug it in here for sine alpha. Okay. Now that being said, I said you can use any of them because you can. If you wanted to use the cosine squared minus sine squared, you can find sine and cosine of the alpha based on the picture that we've already done, but this is even less work. So 1 minus 2 sine alpha, we had already said was, sorry, let me go look, was 3 over 5. Don't forget that you have to square the sine alpha, and we have to multiply by 2 times the sine alpha. So you need all of those things in order to solve. Now we got to use just our normal PEMDAS. Square your fraction first. I've got 1 minus 2 times 9 over 25. When I multiply 2 times that fraction, think of it as 2 over 1. So now I've got 1 minus 18 over 25. And then we can get like denominators to add or to do 1 minus 18 over 25, right? That's like 25 over 25 minus 18 over 25. And that's the same thing as 7 over 25. Anybody have any questions on that? So we're just using a new identity. We're still kind of doing exactly what we did before, just a new identity, a new thing to plug into. Can we do the last one on this page? This one says cosine of beta divided by 2. Which formula or which identity am I going to use for this?
The half angle of cosine.
The half angle of cosine, which there's only one, so we should all have the same one. Plus or minus square root of 1 plus cosine of beta all over 2. Do you know what cosine of beta is?
Yeah.
The answer is yeah. We have our whole triangle and they actually gave us cosine of beta. They gave us 5 over 13 as cosine of beta. So I'm gonna go plug that in. Five over 13 goes in for cosine of beta. The trick part of using this identity is done, and I think it's easy. It's the algebra stuff that all that simplifying that we're gonna have to deal with. Let's make the whole numerator a big fraction. So let's do 1 plus 5 over 13. You might need to multiply by 13 and top and bottom here so that you have that. Plus or minus root 13 plus 5 all over 13, all divided by 2. Plus or minus 18 over 13, all divided by 2. Now I've got this big fraction over 2. How do I get rid of the fraction within a fraction?
Multiply by the reciprocal.
Multiply by the reciprocal. So it's like 18 over 13 times 1/2, which I actually can simplify. 2 and the 18 break down to be 9. Nine over 13. And generally when we do unit circle problems, we'll have stopped simplifying about by this point, but these are really simple numbers, so we can keep going. And I actually just want to go 2 more steps. What is the square root of 9? 3. What's the square root of 13? Root 13. Can we have a radical like that in the bottom? No, so let's rationalize it. Okay. So I've got this. Now, we're almost done with this problem. We're not quite done with it. I have plus or minus in my answer, and I actually believe that we know whether it's plus or minus. Okay. We're doing that half of my angle beta. We want to know what that angle is between so that I know what quadrant I'm in to know if cosine is positive or negative in that quadrant. Okay. Beta is between 3 pi over 2 and 2 pi, right? So it's in the 4th quadrant. What's the biggest angle it could be? What's the biggest angle in the 4th quadrant?
3.
No, there's angles bigger than that. When do you stop being in the
345.
even more?
360.
360.
Oh.
You can go all the way up to 360. That's the biggest it could be. So if beta was the biggest it could be, it would be 360, and we would have to divide that by 2 because I want half of that, right? That means the biggest of b divided by 2 could be 180. You guys okay with that? So the biggest it could be is 180. Now the smallest it could be, what's the smallest angle in quadrant 4? The smallest angle in quadrant 4.
70.
270. So let's think about what half of 270 is. I think last class we said it was 135. So that means B started over here in quad 4. But once I divide it by 2, it's somewhere between 180 and 135, which means it's now in quad 2. Is cosine positive or negative in quad 2?
That's negative.
Negative. So what should my answer be, positive or negative?
Negative.
Negative. Good. All right. Once you've done that, let's go back to the beginning of 5.4 notes. Those are doing awesome. Okay, so number 5.4 says find the exact values using the half angle identities. So we're gonna look at our half angle identities and we're gonna solve those based on what's given to us. Okay. So first one is cosine of 15. Now, before I do anything with this, I'm gonna think of this, cosine of 15 is the same thing as cosine of what angle divided by 2?
30.
30. So that means when I go to plug in, I'm gonna think about my theta or my x is 30. All right, so the identity that we have is plus or minus square root of 1. We just did it this way, right? 1 plus cosine of theta, which in this case is now 30, all over 2. We're using one of our unit circle angles, so we actually know what cosine of 30 is. Who remembers what cosine of 30 is? Ava?
Root 3 over 2.
Root 3 over 2, yeah. So we got 1 plus root 3 over 2, all over 2. We're gonna simplify just like we did last time. However, we're gonna get some ugly radicals, so we maybe aren't gonna go as far as we did last time, but we're gonna go as far as we can. So let's combine those fractions, that fraction of root 3 over 2 with 1 on top. So I get plus or minus 2 root 3 all over 2 divided by 2. A mistake we sometimes make is that this radical doesn't go all the way down to the denominator. Everything's under the radical right now. But now I want to multiply by what to get rid of that 2 in the denominator? Or the big ugly fraction, how do I get rid of that?
Multiply by 1.
Multiplied by 1/2. So this 2 goes away. And so I get 2 plus root 3 all over 4. The last step I really want us to do, I cannot do the square root of 2 plus root 3, right? I can't do that. Can you do the square root of 4?
No.
Good, so my denominator is just going to be 2. Now, remember on the last one how we had to think about whether this was going to be positive or negative? We actually know where my half of my angle is going to be. I actually know that half of 30 is 15. That's going to be in quadrant. What quadrant is 15 in?
1.
1? Is cosine positive or negative in quadrant 1?
Positive.
Positive. So I actually can just kind of delete both of those things and just keep it as is. We could have actually done that step at the very beginning. As soon as we wrote it down, we could have looked at our plus or minus and been like, is it going to be plus or minus? We just didn't. So if it's easy for the next one, we might do that early for the next one. All right, let's do the same idea over here. So we're doing tangent of 67.5. I actually don't know what divided by 2 to get me 67.5, but I can do 67.5 times 2 in the calculator to see what goes as my numerator. See what I divided by 2 to get there. 67.5 times 2 is going to be 135. And so now we're going to use this and my tan half angle identity, plus or minus big radical 1 minus cosine of 135 over 1 plus cosine of 135. Do you remember what cosine of 135 is?
It's negative root 2 over 2.
Negative root 2 over 2. If I like to remember it was negative root 2 over 2. So I'm going to replace these with negative root 2 over 2. And then just like before, I'm going to use algebra to simplify. Now, we can do this now. I forgot to do it earlier, but like, let's get rid of that plus or minus. Is tangent of 67.5, is that going to be positive or negative? Which quadrant is 67.5 in? 1 is tangent positive or negative in quadrant 1, it's positive. So I actually don't even need to carry that positive minus through, bless you. I'm good with that. I'm just gonna carry my radical through though and do 1 minus negative root 2 over 2. And then 1 plus negative root 2 over 2. Just like we did last time, let's get like denominator. So I'm essentially multiplying by 2 on top and bottom to my 1. So I get like fractions that I can combine. 2 plus root 2 all over 2. All of that's being divided by 2 minus root 2 over 2. Feels big, ugly, and scary. I really think I just need one more step. Some teachers might have you go farther. Based on where we are this year, I'm not really that worried about simplifying much more than that. Let's multiply by the reciprocal. So let's multiply by 2 over 2 minus root 2. And notice that my 2's cancel. So I'm just left with 2 plus root 2 over 2 minus root 2. Technically, we could keep going, but I think that's enough simplifying for us at this point. Let's do number 2 and then we can be done for today. We won't have done the solving, but I'll make a video on those few solving problems that I want you to do. Number 2 is super basic. It's what we were just doing up here, where all you're going to do is give me an answer, sine something, cosine something, tangent something. So we just had to figure out which identity this one looks the most like. So this first one, 1 minus cosine of 47 divided by 2. Is that a double angle or a half angle? It's a half angle. Is it sine, cosine, or tangent? Sine. So it's going to be sine of, and it's what angle divided by 2?
47.
47. So that's the same thing as sine of what, 23.5? Are you guys okay with that? I know there's not a lot of work there, but all we're doing is kind of matching and comparing. All right, letter B, we might have to do a little manipulating, but what does this one look the most like?
Double
Which one?
of the cosine.
Cosine. Now, does it look exactly like double of cosine?
No.
What's the problem?
It's flipped.
You need to flip it. Remember, we did this already in 5.3, so we're gonna switch the order. We're gonna make it negative cos squared of 87 plus sine squared 87. And then we're gonna factor that negative out. Once I do that, now it looks like a cosine double angle. So this is now the same thing as negative cosine of 2 times 87. Which is going to be 174. Don't forget your negative out front of that cosine. Oh, you guys are doing awesome. Let's look at that last one. 2 tan 73 over 1 minus tan squared 73. What does that look like? Half or double?
The double of the tan.
Double of the tan. So I'm gonna do tan of 2 times what? 73, good. It's just that simple. I just want you guys getting in the hang of, like, it's just the angle that you see. It's not any harder than you think. Don't make it more difficult than it has to be. So 146, I think. All right. We've done a lot today. I think you can do the 5, 3, 5, 4 homework like this. I'll make a little video with these few problems that we haven't gotten to, but for the most part, I think that you've gotten a lot that you can handle, okay? Tomorrow we'll go over homework, we'll review anything need be, and then we're just gonna review for the test. Yeah, Megan. Yep, so sorry, I ran away too fast. I have 1,000,005 papers to pass back to you guys tomorrow. Oh, shoot.